In this video, we will learn how to solve for x in an exponential equation using the one-to-one correspondence of exponential function. Now, this one-to-one correspondence states that if x to the a and x is equal to x to the b, since the bases are the same, then the exponents a and b must be equal. If we are given an equation in which the bases in the two sides are not the same, first we have to rewrite one or both sides of the equation for us to get the same base. Once we have the same base, we can equate the resulting exponents and solve for x. Let's solve for the value of x in the following exponential equation. First, let's say we have 5 to the 2x plus 1 is equal to 5 to the x minus 3. In this case, we have the same base in the two sides of the equation. So we can ignore the base. We can now ignore the base and equate the exponents. So the exponents are 2x plus 1. That must be equal to x minus 3. To solve for x, let's isolate x on one side. So 2x, let's transpose this x to the left side. It becomes negative x. Then we copy negative 3 on the right side. And we transpose 1 to the right side, so it becomes negative 1. Let's simplify this equation. 2x minus x is x, and negative 3 minus 1 is negative 4. Next, let's say we have 4 to the x minus 3 is equal to 1 divided by 32. First question, well, in this case, we do not have the same base. So first we have to look for the common base. Can we use 4 as the common base? In other words, can we get 32 using 4? Let's try. So 4 times 4 is 16. Times 4 is already 64. Therefore, we cannot use 4 as the common base. Now, in such a case, we can consider a smaller base. So, how about 2? Can we get 32 from 2? Yes, because 32 is actually 2 to the 5. Okay, so if we use 2 as the common base, we have to write 4 as 2 squared because 2 times 2 is 4. Since 4 is raised to the exponent 3, we have to multiply the exponent 2 by the exponent x minus 3. Then, on the right side, we have 1 divided by, again, 32 is 2 to the 5. Let's simplify the exponent on the left side. So let's distribute 2 to the two terms. So we have 2 times x, 2x. 2 times negative 3 is negative 6. Now, if we want to write this expression in the numerator, we have to get the reciprocal of this expression. So we get 2 to the negative 5. Remember, from one of the laws of exponents, if you get the reciprocal of an expression, the exponent becomes negative. Now we have the same base, 2. So we can ignore the base and we have to equate the exponents. 2x minus 6 is equal to negative 5. To solve for x, let's isolate x on one side. So 2x, then we copy negative 5 on the right side. If we transpose negative 6 to the right, it becomes positive 6. So 2x is equal to negative 5 plus 6 is 1. Now we have to divide both sides by 2, so we get x is equal to 1/2. This time we have 4 to the 3x plus 5 is equal to 16 to the x minus 4. Now notice that the bases are different. So first, we have to look for the common base. Can we use 4 as the common base? Yes, because 16 is 4 times 4. So we can copy the left side because it already has the base 4. Then we have to write 16 as 4 squared. Now since 16 is raised to the exponent x minus 4, we have to multiply the exponent 2 by x minus 4. So let's simplify the exponent on the right side. Let's distribute the exponent 2. So 2 times x is 2x, and 2 times negative 4 is negative 8. Now we have the same base, so we can ignore the base and equate the exponents. Exponents, 3x plus 5 is equal to 2x minus 8. To solve for x, let's isolate x on one side. So 3x, let's transpose 2x to the left side, so we have minus 2x. Then copy negative 8. Then we have to transpose 5 to the right side, so that is minus 5. 3x minus 2x is x, and negative 8 minus 5 is negative 13. Lastly, we have 3 to the 4x plus 2 divided by 3 to the x minus 1 is equal to 1 over 27. Now we have here the base of 3, but on the right side we have 27. So it looks like we have to rewrite this 27. And yes, we can use the base 3 as the common base because 3 times 3 times 3 or 3 cubed is 27. Okay, by the way, since these two expressions in the numerator and denominator have the same base 3, we can simplify this by copying the base 3. And since this is division, we have to subtract the exponent. So 4x plus 2 minus x minus 1. That is equal to, again, 1 over 27 is actually 3 cubed. Let's simplify the exponent on the left side. 4x minus x is 3x. 2 minus negative 1, or 2 plus 1 is equal to 3. Then, if we want to write this expression in the numerator, we can get the reciprocal of 3 cubed. And the reciprocal of that is 3 to the negative 3. That is the opposite sign of the exponents. Since we now have the same base, we can ignore the base and equate the exponents. Exponent, so we have 3x plus 3 is equal to negative 3. To solve for x, let's isolate x on one side of the equation. So 3x is equal to, copy negative 3 on the right side, then transpose plus 3 to the right side, so it becomes negative 3. Let's simplify the right side. Negative 3 minus 3 is negative 6. And let's divide both sides of the equation by positive 3. So the left side becomes x. And on the right, we have negative x divided by 3, that is negative 2. If you have any question, please leave a message. A comment rather.